Guys, today's video is on linear programming. What linear programming is, uses inequalities or even equations to find the optimal, or in a lot of cases the maximum solution. And when you do this, we're going to follow a couple steps. We're going to write inequalities based off a word problem. We are going to graph those and shade accordingly, and then we're going to identify all the vertices in our shaded region and test those to find the maximal value. Okay, let's do number one. Number one says we have the smallest plane in this airline, offers first class, tourist class tickets. That's going to be my F and my T. Let's say F is first class, and then T is tourist class. And I'm going to just put that in the graph. Doesn't matter which one's Y or X. Let's just make F be like the y-axis and then T be the x-axis. So now we have to come up with some inequalities. It says between first class and tourist class, they can hold a maximum of 50 passengers. That means if we take F and T added together, can't be more than 50. Next one says, in order to charter a flight, the airline must sell at least 8 first class tickets. That means in order to charter a flight, first class must be at least 8. And then pick a different color. It says at least 20 tourist class tickets must also be sold. These are your 3 equations. The last, inequalities. The last sentence says here the company makes a $40 profit for the first class tickets and $30 profit for the tourist class tickets. That's going to be your objective function down here. Talking about your profit is going to be $40 for each first class ticket and $30 for each tourist class ticket. So your equation is, the objective function is always going to be an equation, and your constraints here are always going to be inequalities. Let's graph these 3. So in blue, solving for y, in this case f, get f less than or equal to be negative t plus 50. First, I'm going to scale my graph. Let's maybe go up by 4s. This way, let's also go up by 4s. It's going to be tough to fit this in. And so on. Maybe I erase it and skip a few before I keep writing it. I'm going to pause the video and do that. I did enough. I think there's a mistake here. And this is 40, and this is 48. Did I make that same mistake here? No. Okay, I could keep going to 56 maybe. In blue, your y-intercept looks like it's 50, so I'm going to estimate that it's right here. And then going down 1 over 1, and you're going to shade below. So make that line. Let's do the next one. We got y to be greater than or equal to 8. So at 8, it's going to be a horizontal line. And you're shading above, which is all this. And then in orange, t, which is a vertical line, so it's x is greater than or equal to 20. That's going to look like this. 20 is in between 16 and 24, so that would be right here. And it's vertical. And you're shading greater than that, so it's to the right. So let's look at where all 3 colors intersect. We have here, we have here, and we have here. And here. Try to identify where the vertices are of that triangle. So your 3 points are 28, 48, and 2030. These points would be different if we changed what F and T on the axes were. For example, if F was the x-axis. What we're going to do is now plug in 20 and 8 in for F and T. 20 stands for T, 8 stands for F, and see what that equals. We're going to do the same thing for 40 and 8. And then we're going to plug in 20 in for T and 30 in for F and see what that gives us as our profit in our objective function. Plugging the numbers 20 and 8 into the P formula for profit gives us 920. Plugging in 40 and 8 in for T and F into the profit formula gives us 1520. And then plugging in 20 and 30 in for T and F into the profit formula gives us 1800. Your solution is the numbers that gave you the maximal profit. In this case, it is the 20 and the 30. That gives you the highest profit of 1800. The way you write your solution now is by saying you should, the maximal profit would be if tourist tickets were 20 and then first class tickets is 30. Selling those specific amount of tickets would maximize the airline's profit for that particular flight. Again, to recap, you come up with your usually 3, sometimes even more inequalities from the graph. Write down your objective function. Most of the time it has to do with profit. Then we're going to shade, graph, identify vertices. If it's a triangle, we're going to have 3 vertices here. Put those ordered pairs into the objective function for profit. Find which one had the maximum value and state your solution. Write down what questions you have in this example and let me know in class. I know it's going to take a while, but I do want you to try example 2 and then come up with an answer. So try it now. I'm going to just write it real quickly, and after you pause, check your answer with me. Here is the answers. Pause the video, check your work, make sure you have your variables defined, make sure you have your constraints correct, shaded correctly, your objection function in terms of income or profit was fine, and you tested the correct vertices. Let me know what questions you have, and have a great night.